When an object is immersed in a fluid, there is a loss of weight, and this is because the object experiences a buoyant force. Here it experiences an upward buoyant force while its weight acts downwards. Now that we know an object loses its weight in water, let us try and calculate what would be its weight in water. So here's the object in water, and there is a force acting downwards, which is the weight of this object, and we will call this, say, 20 newtons. There's an upward buoyant force, and this upward buoyant force, maybe it would be 7 newtons. So let's write that out. Weight in air of this object is 20 newtons. The buoyant force is acting upwards, which is 7 newtons. Now, because there's an upward force, you'll definitely agree the body has lost weight. What would be its weight in water? It would be 20 newtons minus the upward force 7 newtons. So this weight in water would be 13 newtons. There is a loss of weight. Weight in air is 20 newtons. Weight in water is 13 newtons. Why? Because there was a buoyant force of 7 newton acting upwards. Let's take up another example to understand this concept. So again, I have a body in the liquid, and now the weight of this body, say, is 80 newtons. And when this body is placed in water, it's going to lose its weight. So let the loss in weight, say, be the weight in water be 65 newtons. So what is the loss of weight? 80 newtons in air, 65 newtons in water. So you definitely agree that the loss of weight would be 80 minus 65, and that would be 50 newtons. This is the loss in weight. Why was there a loss of 50 newtons in weight? Because the buoyant force must have been 15 newtons. So there was an upward buoyant force of 15 newtons acting on this object. So from this we could say now that the loss in weight is equal to buoyant force. Greater the buoyant force, more is the loss in weight. Archimedes principle. Archimedes principle gives us the magnitude of this buoyant force. It tells us exactly how much is the buoyant force when an object is immersed in a fluid. Let's read it. When an object is wholly or partially immersed in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced. Now here's a little arrangement that will help you to demonstrate what Archimedes principle says. So I have an object immersed in this liquid. The minute the object is immersed in this liquid, you will definitely expect water to overflow and fill this vessel. Now what is interesting is, now that you have placed the object in the water, there is a loss of weight. And why is there a loss of weight? Because an upward buoyant force is acting on that object. If you find the weight of this object, of this water, weight of water displaced, they will be equal. So the loss of weight of that object is equal to the weight of the water displaced. This is what Archimedes is saying. The upward force, which is a loss of weight, is equal to the weight of the fluid displaced. Let's take up another example. Here is an object again placed in water, and because of that water gets displaced, and whatever the water is displaced, we collect it in another container. Now the weight of this object we will take as 100 newtons. So there's a downward force here of 100 newtons. So 100 newtons is the weight in air. Now when the object is put in water, it's going to lose its weight. So let its weight in water be 80 newtons. After having put it in water, the weight has become less, and now it is 80 newtons. So the loss of weight will be 100 in air minus 80 in water, which is 20 newtons. That is a loss in weight. Now what is surprising is this weight of the water displaced here will also be 20 newtons. If you weight, you'll find that the weight of the water displaced is also 20 newtons. And the buoyant force is also 20 newtons. Buoyant force is the loss of weight that we have seen in the earlier video, how the buoyant force is equal to loss of weight because the object loses weight because of buoyant force. So the loss of weight and buoyant force are equal. So now we can come to a new relationship, and that is when an object is immersed in a fluid, there is a loss in weight. Why is there a loss in weight? Because there's an upward buoyant force. So the loss in weight is equal to the upward buoyant force. And this upward buoyant force is also equal to the weight of water or fluid displaced. All these three quantities are equal. Let me mark these three quantities here. The loss of weight, the weight of the water displaced, and the buoyant force. All are 20 newtons in this example. So remember again, the loss in weight is equal to the upward buoyant force is equal to the weight of the water displaced. To further understand why some objects float and some objects sink, we need to know a quantity called density. Now the density of a substance is defined as the mass of the substance per unit volume, which means density is equal to mass of the substance over its volume. Now the SI unit would be, we know the SI unit of mass is kg and the SI unit of volume is meter cube. So SI unit for density will be kg per meter cube, or it could be written kg meter raised to minus 3. Let me give you some more examples. If I say the density of wood is equal to 800 kg per meter cube, what do I mean? Here I have a block of wood whose volume is 1 meter cube. Volume 1 meter cube means length is 1 meter, breadth is 1 meter, and the height is 1 meter. And this entire block has got some mass. The mass is 800 kgs. So the mass of 1 meter cube of wood is 800 kgs. That is, density of wood is 800 kg per meter cube. Kg per meter cube. Here there's 1 meter by 1 meter, length, breadth, height is 1 meter. So this entire block of 1 meter cube, the mass is 800 kg. Let's take the density of gold. The density of gold, this is 19,300 kg per meter cube, which means if I take a block of gold having 1 meter cube volume equal to 1 meter cube, its weight will be 19,300 kgs. So the weight will be 19,300 kgs. That is the meaning of density, the weight of 1 meter cube. We now learn another quantity called relative density. It is a ratio of the density of a substance to that of the density of water. So relative density is density of substance over density of water. Now if I want to know the density, relative density of like silver, so relative density of silver would be density of silver over density of water. Now the density of silver is 10.8 kg meter cube and water 1000 kg meter cube. So you see the relative density is 10.8. Another important point is the units cancel off completely. So relative density has no unit. Very important. Relative density has no unit because it is a ratio of the same quantities. Because it is ratio of same quantities. When does an object float? Now when the density of the object, the density is an important factor, is less than the density of the fluid, it will float. And when this happens, when the density is less, the buoyant force becomes greater than the weight of the object. That's when it floats. So let me just summarize it again. So density of object is less than density of the fluid. And when it is less than the fluid, then the buoyant force becomes greater than the weight of the object. And that's when an object floats. Now when does an object sink? When the density of the object is greater than the density of the fluid, then the buoyant force becomes less than the weight of the object and the object will sink. So density of object, for it to sink, the density of object should be greater than density of the fluid or maybe water. And when this happens, the buoyant force becomes less than the weight. So the buoyant force is less downward, the weight, buoyant force is the upward force, right? So this is wrong. The buoyant force is less while the weight is more. And that's when the object will sink. This is the weight here, and this is the buoyant force. And here just the opposite happens. Here we have the buoyant force, which is large, and the weight is less. So the object will float.